Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our actuarial students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today. A perpetuity costs 77.1 and makes annual payments at the end of the year. This perpetuity pays 1 at the end of year 2, 2 at the end of year 3, and so on, n at the end of year n plus 1. After year n plus 1, the payments remain constant at n. The annual effective interest rate is 10.5%. Calculate n. Compare this perpetuity to a regular increasing perpetuity starting at time 2. They would make the same payments at time 2, 3 through n plus 1, but then at time n plus 2, the regular increasing perpetuity pays n plus 1, while this perpetuity pays n, resulting in a difference of 1 between two payments. At time n plus 3, the regular perpetuity pays n plus 2, while this one pays n, resulting in a difference of 2 between two payments, and so on. Hence, the difference between the two perpetuities, the regular one and this one, both starting at time 2, amount to an increasing perpetuity starting at time n plus 2, a regular increasing perpetuity paying 1, 2, 3, 4, 5, and so on. This means that the perpetuity we are considering can be viewed as a regular increasing perpetuity, so perpetuity paying 1, 2, 3, and so on, with first payment at time 2, from which an identical increasing perpetuity, but with first payment at time n plus 2, is subtracted. Now recall these three important formulas. That v to the n times 1 is the present value at time 0 of a single payment of 1 at time n. V to the n times 1 over d is the present value at time 0 of a perpetuity of 1, level perpetuity, with first payment at time n. And v to the n times 1 over d squared is the present value at time 0 of an increasing perpetuity of 1, 2, 3, and so on, with first payment at time n. So recalling this, we can write the value of the perpetuity that we're working with as a difference of two perpetuities. First one is v squared times 1 over d squared, and the second one is v to the n plus 2 times 1 over d squared. The difference of two increasing perpetuity, one starting with the first payment at time 2 and the other one with the first payment at time n plus 2. So that's the same as v squared over d squared times 1 minus v to the nth. But if we multiply that v squared by I squared, that will become d squared. So it will cancel with d squared. And then 1 minus v to the nth over I is a angle n. And then it's multiplied by 1 over I. To make up for the fact that we multiplied the numerator by I squared, we multiply the denominator by I squared. I times I. So what we are left with is that this is a angle n over I. And we know this must equal to 77.1, and I is 10.5%. So a angle n divided by 0.105 is 77.10, and this tells us that angle n at 10.5% is 8.0955. You can now use a financial calculator. For example, in BA2 Plus Pro, you put in 8.0955 for the present value, -1 for payment, 10.5 for the IY interest rate, 0 for future value, and compute n, and you get 19. Alternatively, you can just solve for n. You know that a angle n is 1 minus v to the nth over I. I is 10.5%, so that n will be natural logarithm of 1 minus 8.0955 times 0.105 the whole thing is divided by a natural logarithm of 1.105, and that comes out to be almost exactly 19. Either way, we get 19, so that's the answer C. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries and belongs to the Society of Actuaries, but the solution is mine. Good luck in your studies and good luck on the test.